All right, question 3. A student heated a solid sample of sodium carbonate which contains X amount of water for 1 minute to remove the water and determine a value for X. Figure 3 shows the apparatus that they used and table 1 shows the results recorded. We're given the mass of the empty evaporating basin. We're then told the mass of the evaporating basin and the solid before heating. So immediately I'm thinking I can work out the mass of the solid before I start to heat it. We've then been given the mass of the evaporating basin and the solid after heating for 1 minute. So again, I can work out the mass of the solid at the end. So they want us to use the table to calculate a value for X in that formula and give our answer to 2 decimal places. So the first thing I'm going to do then is start by working out the mass of solid before heating. And I'm going to do that by using the total mass of the solid and the basin, which is 25.47, and I'm going to subtract the basin, which gives me a mass of 1.12 grams. So we can assume that's the total mass of this substance, including the water. I can then work out the mass after, which is going to be 24.92, subtracting the basin again, which will give me 0.57 grams. Now, if we assume then that all the water has been lost at this point, then we can assume that 0.57 grams is the mass of just sodium carbonate. That means then we can work out the mass of water by taking the starting mass and subtracting the mass of the sodium carbonate. So our mass of water is going to be 0.55 grams and our mass of sodium carbonate is going to be 0.57 grams. So I just move that down now. Okay, so we've then got, I'm just going to rewrite this so I can follow it. In fact, I'm going to write sodium carbonate mass equals 0.57 grams and water mass equals 0.55 grams. Okay, so I want to know then what's the ratio of moles of sodium carbonate to water. That's the only way I'm going to be able to get X here. Now at this point I've just got masses and I need to be able to work out the number of moles. So I'm going to need the molecular mass of both of these substances. So using my periodic table I can work out sodium carbonate, which I get as 106, and water, which comes out as 18. So to work out N then, I can just do a simple divide, and the number of moles of sodium carbonate should come out as 0.0054, and the number of moles of water should come out at 0.0306. Notice that on your calculator it is 0.0305 recurring, so we should round that up there. So I've then got the number of moles of each of these substances. Now this could be a ratio, but it's pretty complicated. The numbers are pretty difficult to use, so I'm going to simplify that as much as possible. I'm going to do that by dividing each of these numbers by the smallest value. The smallest value being 0.0054, meaning that the simplest ratio here is going to be 1 sodium carbonate for every 5.68 waters, giving our final answer as 5.68 as the value for X. Now we're then told that the correct value for X is actually 10. Now 10 is much higher than what we calculated. So we're thinking about here then, why does the experiment find there to be much less water? What is the reason that our calculation showed there was much less water present? Well, that would suggest then that we haven't identified the right mass of water, and actually in this experiment, not all the water has been lost. Thinking about the apparatus, thinking about the actual experiment that they've done, they've heated this substance up, but they've actually only heated it for a minute. So they clearly haven't heated it long enough for all the water to have evaporated. Now the next question then gets us to think about, well, what could we do better? Well, we want to be certain that all the water is lost. Now we could just say, oh, well, we'll carry on heating it for a really long time, but how can we be certain that this procedure will definitely show that all the water has been lost? Now, we know that they're measuring the mass of the substance after, so what they could do is continue to heat it until a constant mass is reached. So that might mean that they're going to record the mass every minute. They're going to keep doing it until they find that that mass is constant, because that way we can be certain that all the water has been lost from that product.